Hi all, this video is going to be looking at metallic solids and their properties. So starting off, what is a metallic solid? A metallic solid is a giant three-dimensional network made up of positive nuclei and a sea of delocalized electrons. Bit of a weird statement at first, but I will explain it. Basically, metallic solids refer to anything, any type of metal. So it could be magnesium, it could be calcium, it could be gallium, could be mercury, it could be tungsten, whatever you want, just as long as it is made of one particular type of metal, and that is how we recognize a metallic solid, if it just contains one type of metal atom. So taking magnesium as an example, magnesium has the symbol Mg and electron configuration of 282. So the basic structure of magnesium atom is you have your nucleus, and in your nucleus you have your 12 protons and lots of neutrons, and then you have your electrons which kind of orbit around the outside. And magnesium has 3 electron shells. It's got 2 in the first one, 8 in the second, 2 in the third, and we call that third shell there the valence shell. So it's got 2 valence electrons, and these are what the delocalized electrons are. They are electrons that can go wherever they please. They're not focused around the magnesium atom, they are free to flow all throughout the solid. What you'll also notice is that the nucleus has a positive charge because it's got positively charged protons and neutrons with no charge. So what this picture down the bottom represents is the little circles with the positive, they are the nuclei of different atoms. So a nucleus of a magnesium atom, a nucleus of a magnesium atom, another nucleus. And then these little negative charges, these are the delocalized electrons. So they represent these valence electrons, which are then whizzing all throughout the solid, and they can go wherever they want. So they're not just focused on one particular atom going around and around and around like the rest of the electrons. They are free to move all throughout the solid, all throughout the billions and billions and billions of magnesium atoms in that particular solid. So that's what a delocalized electron represents. The thing that holds metallic solids together is called the metallic bond, and what it is a strong electrostatic attraction between the nuclei and electrons. So just like ionic solids, it's the attraction between the positive nuclei and the negative delocalized electrons, and that attraction there is very, very strong, and this is what leads to the properties of metallic solids. So starting off with melting and boiling points, majority of metallic solids have high melting and boiling points. This is because the electrostatic attraction between the positive nuclei and delocalized electrons is very strong and takes a lot of energy to overcome. Now, I didn't stress this in the ionic video, but if you're after metal excellence, you have to get this point across. So because the force is very strong, it takes a lot of energy to overcome, and that's what gives the high melting or boiling point. Now, there are exceptions to the rule. So gallium's an example, because gallium is that metal, that quite cool metal that will melt in your hand if you leave it long enough. Mercury, which is a liquid at room temperature anyway, and there's some other metals that will melt or boil at slightly lower temperatures than you'd expect. You guys are not expected to be able to discuss these. The reason why becomes quite complicated, and it's not something that's assessed at secondary school level. Right, on to conductivity. All metallic solids conduct electricity. The reason being, this is because the delocalized electrons are free to move and carry the charge. So if you remember what I mentioned or said in the introduction topic, to conduct electricity, you need mobile charged particles. So in this particular case, you have all of these delocalized electrons having a negative charge, and because they are delocalized and free to move around, they are mobile. So mobile charged particles. Malleability and ductility. So all metallic solids are malleable ductile, which means you can hit them into shape or draw them into a wire. The reason why this is because the metallic bond is called non-directional. So when we looked at ionic solids, their bonding either went that way, or thinking three-dimensional space, that way, but they went in a certain direction. Whereas with a metallic bond, because these electrons are going all over the place in both the X, the Y, and the Z axis, they are bonded to all the atoms around them, not just the ones next door to them or up and down. They are bonded to atoms all around them in any direction whatsoever. So what this means is when a force is applied, atoms can move over each other without disrupting the metallic bond. So if you look at a little picture, if you take a hammer and smack that block of metal that way, these atoms will slide over to the side, but the metallic bond is still intact because you still have delocalized electrons which are whizzing around between all of these different nuclei. Last but not least, we have solubility, and metallic solids are all insoluble in water. We need to remember that solubility means, does it dissolve in water? So not does it react, like sodium and calcium, which are very reactive metals. When you stick them in water, they will bubble and fizz and possibly explode, but will it actually dissolve in water? And no metallic solids will dissolve in water. Reason being, the technical explanation is the attraction between the atoms and water molecules is less than the attraction between the atoms themselves. So if you take a magnesium atom, let's draw you a lovely picture. 2 magnesium atoms and two water molecules. So the attraction between the water and the magnesium, represented by this red line, that attraction there is less than the attraction between individual magnesium atoms or, get green, individual water molecules. Okay, so we're saying the attraction between the magnesium and the water is less than the attraction between magnesium atoms and the attraction between the water molecules. So because this red attraction here is less than these two combined, that makes metallic solids insoluble.